Hello again. The SAC-64 language has now if statements, and they come with bytecode optimization. Let's have a look. Let's open the newest example that is bundled with the SAC-64 compiler. It shows how to use the if statements. In short, the example increments a digit value in the top left corner of the screen. It first resets the digit value to 0, and each time the program is run, it will increment the digit value by 1. After reaching the value 9, the program will reset the digit value back to 0. So the program called example04 defines first three constants. The constants value 0 and value 9 are for character code values for digits 0 and 9. The constant white represents a white foreground value for the digit. Then the program defines two variables. Digit is the counted value, and foreground is the foreground color for the digit. These variables point to memory locations that correspond to the top leftmost character on the screen and its foreground color. In the body of the example program, there is an assignment statement and two nested if statements. The assignment statement resets the foreground color of displayed digit to white. Then the first if statement checks if the digit value is less than 0. If it is set to 0. Otherwise, the else part of the first if statement is executed. It contains a nested if statement that checks if the digit value is greater or equal to 9. If it is, it will be set back to 0. In all other cases, the digit value is incremented by 1. So when you compile and run the program for the first time, it will set the digit value to 0. When you run the program for the second time, the digit value is incremented by 1. And this will happen each time you run the program. Once the digit value has reached 9, it will be set back to 0. The program is actually interactive in the sense that you can set the digit value manually. When the program is run, the digit value is either incremented by 1 or set back to 0 depending on the manually set value. Although the if statement seems to be rather primitive, there was some room for the bytecode optimization. In fact, there are 4 cases for the if statements to be considered. The first case is the one where the expression evaluates to true or false during the compile time. Then the compiler can deduce which of the two blocks gets always executed. In effect, the compiler can then drop out the other block from the resulting bytecode altogether, as if there was no if statement in the first place. This may seem first like a strange use case, however it is very useful. For instance, you can define a constant like debug that controls the compilation of statements used for debugging a program. The best part of this is that when the debug constant is given the value false, all the statements used for debugging are discarded from the final program code as if they were never there. The second optimization case is the one where the Boolean expression is a single Boolean variable. Then the value of the Boolean variable can be used directly in the comparison of an if statement. This results in a very compact conditional bytecode. The third optimization case is the one where the Boolean expression is an inequality expression. Then the inequality expression can be used directly in the comparison of an if statement. The last case to be considered is the one where the expression is a generic Boolean expression. In this case, no optimization is applied. Then the expression is fully computed with the resulting Boolean value in the accumulation register. It is then used to determine which code block is executed in an if statement. All this deduction happens in the SAC-64 compiler on the background when compiling the source code, and the programmer doesn't have to worry about it at all. So that is what the if statements look like in the SAC-64 language. It is really a minimalistic implementation, but it's definitely a step forward. As before, I'll keep on working with the compiler. Thanks for stopping by and see you soon!